Today we're going to be talking about properties of parallelograms. Our objective is that we'll be able to verify characteristics of parallelograms and use properties of parallelograms to solve problems. So what is a parallelogram? A parallelogram is called a parallelogram because it is a quadrilateral with both pairs of opposite sides parallel. So in this example, QR would be parallel to PS, and QP would be parallel to RS. Some properties of parallelograms are that both pairs of opposite sides are congruent. So these sides are congruent, and these sides are congruent. One pair of opposite sides is congruent and parallel. So if the side is parallel, we also would need to know that it's congruent. Both pairs of opposite angles are congruent. So angle P would be congruent to angle R, and angle Q would be congruent to angle S. Consecutive angles are supplementary, just like when we talked about parallel lines. So if P is 70, Q would have to be 110. And if Q is 110, then R has to be 70. Remember, this means add to 180 degrees. And then finally, the diagonals bisect each other, which means cut in half. So if we have the diagonal PR and the diagonal QS, they cut each other in half, so this piece would be the same as this piece, and this piece would be the same as this piece. So examples, decide whether the figure is a parallelogram. Well, in number one, we know that one pair of opposite sides are are parallel. That's not enough to know that it's a parallelogram. So no, only one pair of sides is parallel. In number two, we're looking at some angles. So the opposite angles are congruent, which is good, but we don't know about this angle here. But what about the consecutive angles? Are they supplementary? 117 plus 64 would give us 181 degrees. So no, this is not a parallelogram because the consecutive angles are not supplementary. In number three, we have sides that are congruent and we have sides that are parallel. However, the rule said one pair has to be congruent and parallel. These are different sides. So this is no, because it's one pair parallel and one pair congruent. And finally, we have congruent opposite sides here and congruent opposite sides here. So yes, this is a parallelogram because both pairs of opposite sides are congruent. Now what if we know this is a parallelogram? So find the value of each variable in the parallelogram. So we know they're a parallelogram, it's going to follow our 6 rules from the beginning of the notes. So for our x's, they're opposite sides, which we know are going to be congruent. So 3x plus 4 must equal 16. So we're going to subtract 4 on both sides. 3x equals 12. Divide both sides by 3. And we get that x is equal to 4. But we also have a y in here to find. These angles are opposites, therefore they're congruent. So y minus 60 equals 56. Add 60 to both sides. Y equals 116 degrees. What kind of angles do we have in number 6? Those are consecutive angles, which are supplementary. So we need to add them. Set them equal to 180. So 17x minus 24 equals 180. Add 24 to both sides. 17x equals 204. Divide both sides by 17. And we get that x equals 12. Find the indicated angle measures in parallelogram ABCD. So it wants the measure of angle AEB. So A to E to B. That's this angle in here. Well, we don't even need to know anything about parallelograms for that because this angle and this angle are vertical angles. So it's 117 degrees. Angle BAE, angle BAE is this angle here. These, if you look here, we have a triangle. So we know the angles have to add up to 180. So 180 minus 117 minus 23 tells us the angle BAE is 40 degrees. Next, we're looking for angle DAB. So that's this whole thing. 80 plus 40 gives us that angle is 120 degrees. And then finally, EBC, this angle here, we know that consecutive angles add up to 180. So 80 plus 40, we already know that this angle is 120. Plus the 23 we have here, plus whatever this one is, has to equal 180. So if we subtract 120, subtract 23, we get that angle EBC is 37 degrees. Now let's look at one on a coordinate plane. The vertices of quadrilateral ABCD are given, all those points. Plot the points and draw ABCD on the coordinate plane. So A is -1, 3. B is 4, 3. C is 2, -1. And D is -3, negative. So it looks like that. Find the slope of each side. So remember that slope is equal to rise over run, which is going to be the easiest thing to use when doing this graphically. So the slope of EB, to get from A to B, we don't have to go up any, so that would be 0 over run. We go 1, 2, 3, 4, 5. 0 divided by 5 is just 0. What about for BC? Rise, or we go 1, 2, 3, 4, so down 4, and then left 2. Negative 4 divided by negative 2 is 2. Slope of CD, again, would be 0. It's flat, we have 0 run. And then the slope of DA. 1, 2, 3, 4 over 2, which is 2. So is this a parallelogram? Yes, it is, because the opposite sides, AB and CD, are parallel, and we know this because the slopes are the same. So AB and CD both had slopes of 0, and BC and AD both had slopes of 2. That's all for today.